details. So in this problem, you are given a string s and also an integer k. You can choose any character of the string and change it to any other upper character. You can perform the operation almost k times. So return that length of the longest substring containing the same letter you can get after performing the above operation. Basically, we need to replace the repeated character with any of the existing letter. The, that maximum substring, whatever you get, that you need to return. That is the thing we need to do here. Okay. So in this case, if you see AB, replace two A's with B's, will get same characters 4. That is 4, and you can use the two characters to replace that. Similarly, AA, BA, BBA, and K equal to 1. In this case, replace one A in the middle of with B and you form AA, BB, A. So the substring will be, this is the length is 4. So this problem we can solve in different ways. Uh, Means we can take it as a two kind of solutions. One is like a brute force. Always like I will try to understand with the brute force first. Later we can think of the optimized solution. So coming to brute force, oops, brute force approach. For example, you take it. So take it any example like A, B, A, B, and K will be K equal to 2. In this case, what we can do is we need to form all the strings. For example, in this case, right, you can use the nested loops to bring all combinations, meaning all permutations of the string. Like in this case, A, B, A, B, A, and A, B, A, B. Okay. So in this case, once you found all these strings, you need to find, for example, in this case, you need to get the frequency of characters. Okay, in this case, A also 2 and B also 2, right? So the you got the frequency of characters and also you know the K is 2 times. So you need to try to either of the either A or B you replace with the A or B, then you will get the max substring length is 4. Okay, this is one loop. Okay, one time you are getting this many combinations where I equal to 0, maybe j start from 1 to n, means length of the string. So you will get it. Now I equal to 1 and j start from 1 to n. So in this case the substring will be BAB. So here you will get B, BA, and BAB. So again here for each case you need to find the frequency of the numbers. Probably you can use some data structure like a map to find the count, and that max count can be less than or equal to 2. Then you can go ahead and figure out the maximum length. Okay, what we need to return uh, from this particular by replacing the characters. This is the brute force, like keep grows here, like this will be almost like finding the substrings will take n square, and also we need to figure out like the frequency of the substring like character substring, and then uh, we need to loop through the to find the frequency. We need to loop through the string, right? That again will take n. Basically the brute force will be O of n cube actually, n to the power of 3. So this is the worst case solution, I mean brute force. So optimizer solution can be done using map with sliding window, sliding window solution. So in this case, suppose we have AB, AB, okay. So in this case, what we can do is we can try to use the map. Basically, uh, we can start from. Let us take other example because this is actually equal is there. So you can take another example is this one AA. Let me take this one. So this is the string, right? AA, BA, BBA. So what we can do is first we can start from A, okay, and see if the frequency is able to reach whatever requirement we want. So in this case, like a k equal to 1, right? In this example, but we'll take 2 only k here. Let us see. Now, so A, okay, anyway, this is 1 only. This is not matching this one, this particular k count, right? Now let's um, use the another character, like let's increment it. Now you got AB, sorry, AA. Now count is become like a frequency of that particular A become 2 now, okay. One, that is 2. Yes, we are good here. So nothing to replace here. Replace with what? Nothing, right? Okay. So now A, AB in this string, you can see max count is 2 and B is 1. Still AA is 2 is there. Still we can replace AA and we can get max length as of now is 3. Okay. Now A, BA. So now you got the max repeated, like frequency of A is 3 times, but we have only one B, right? So still we can't, still we can get, if you replace two A's with B, then even B is not there. So we can't do much here also. Now max count will be like a 4. Now what another string is A, B, A, B. Yeah, here we can do this. Here actually, if you see, max count is actually 2, 3, and you can replace with two characters. That's what actually K is 2. Two operations we can do. Then this can be replaced. So the what is the output we'll get here? A max length will be 5. If you replace this two A's, sorry, this two A's with B, you will get total 4 here, right? Next string can be, next string is, yeah, okay. Next string could be, you got this K, so that, yeah, you got this K now. Now what we can do is we can try to eliminate A now, and then we can add another string here. So that is A, B from here, A, B, B, A. So we can move to this particular string. Now here also you can see the replacement we can do. In this case, actually, if you see, A is 3 and B also 3, right? So in this case, you can replace two characters anywhere. either A with B or B with A, it continuously you will get, actually you can replace A with B, you will get 1, 2, 3, 4, 5. So you will get the 5 is the answer. So this will be like, will take O of n time complexity, and also space will be where you storing for frequency purpose, right? This also will take O of n time complexity. Let's jump into the code and let's try to write the brute force first and then try to implement the optimized solution afterwards. Okay, let us see here. Okay, so as we discussed, we need to uh, a loop actually to generate all the substrings. So basically, I want to explain first a brute force so that you will get idea what is happening. After that, you will understand clearly what exactly we are doing with optimized solution. So we will take like a the start position. Probably I will take I only. This I will be like a starting I less than n I plus plus for j equal to I, and j less than n j plus plus. So here using this two for loop, actually we are trying to find a substring of all combinations, as we discussed here, this kind of combinations. Okay, so now um, so we need to see that the map actually to store the to find the frequency of the characters. Okay, map byte of type integers. Okay, so here what we will do is basically here we'll start from the start point, actually that is starting point is I, and we will try to see the k traverse till j, that is the ending point, and k plus plus. Okay, here just we are trying to make map of s of k plus plus. Okay, we got this, and once we got this map of things, try to find the maximum frequency maximum frequency of the count, I mean character, in the substring whatever we found till now. Okay, so maximum frequency can be 0 for now, and we'll try to see get the count actually from the map from the map, and if count is greater than max frequency, max frequency will be C. Okay, you got the like whatever the maximum frequency now. So we need to see what is the replacements, basically how we can calculate that. That is actually j minus I plus 1. From this actually we need to minus the max frequency, right? If you know this, then we need to check if replacements is less than or equal to k. In that case, what we need to do is, and also we need to calculate if j minus I plus 1 is greater than maximum length, then maximum length equal to same thing, j minus. Okay, and yeah, once we got this thing, we just return the maximum length here, return ml. This is completely brute force, and it's a of and keep time complete. Mhm. Oh, okay, got it. We need to travel till the end, right? Okay. So this is the brute force, and if you see the time complexity, there are one, two, three nested for loops are there. Basically, this one. Okay. So this is the time complexity of 10 to the power of 3. Now let us solve with the sliding window solution. That is the optimized one. Let me delete this. I think you will get this code again from the GitHub. Okay. Now again, let's try to solve this using sliding window solution. So you can see the map to get the frequency of make map of byte and integer. So you can see maximum count, comma maximum length. We will have the start position also. This all will be 0, 0, 0. We'll slice these things with 0, 0. So we'll iterate from the end position, that from the 0, and this will be less than n plus plus, right? Now as we will just try to see the increment the frequency of these characters. Suppose we found something, uh, if mp map of s of and the frequency is greater than maximum count, then maximum count could be map of s of e. Okay. And now what we can do is we'll see that the window size, like the content string window size is greater than uh, or I mean it is greater than k or not. K is like number of replacements. So that for that what we can do is e minus start plus 1 is greater than minus max count is greater than k whatever we received. In this is the case, then what we need to do is we need to, and we try to increment the starting position. This is what actually we discussed here. So here actually we'll keep increment the sliding window in this case. Okay. Now in this case maximum length could be um, like a n minus start plus 1. Once you are done with all the things, I mean yes, right, we declared already. Yeah. Okay. Yeah, this is the best solution. This time complexity could be O of n and space also